Hi guys, so let's talk about section 9.4, evaluate inverse trigonometric functions. What we want to do in this section is evaluate inverse trigonometric functions and then write or solve trigonometric equations, okay? That's a very oversimplified set of objectives, but that's basically in a nutshell what we're going to be doing. So, I'll just read through a lot of this with you because some of this stuff is not in the textbook and I added it to try and clarify things for you. So hopefully this will go okay for you. And then we'll return to the textbook interpretation of things and just solve some problems, okay? So it says, so far in the chapter, you've learned to evaluate trigonometric functions of a given angle. In this lesson, you'll study the reverse problem, finding an angle that corresponds to a given value of a trigonometric function. All right, so what do we mean here? So we say, suppose you were asked to find an angle theta whose sine is 0.5. So the sine of angle theta is 0.5 or 1/2. Okay. If you think about that for a little bit, you would realize that pi over 6 is an answer, which pi over 6 is 30 degrees. Okay, and that would come from this idea, 30, 60, 90, and opposite 30 is 1. This is root 3, and this is 2. Okay, so sine is opposite over hypotenuse, so I would get 1/2. But what we learned in the previous section, if I go outside of the first quadrant and I place that triangle here with a reference angle of 30 degrees and 60 here, then I would get 1, negative root 3, and 2. And so then you'll see that the angle here is actually 5 pi over 6. It's just 1 pi over 6 shy of pi. Okay? And so it's 5 pi over 6. So, what we're basically saying is the sine of pi over 6 is 1/2, but the sine of 5 pi over 6 is also 1/2. So this creates a problem. When I say to you what angle theta has a sine of 1/2, you can't give me an actual answer because if you look at this, the possibilities carry on forever. I can find every single coterminal angle with these two angles, and that wasn't supposed to happen, and just keep going around and around and around and around forever around the coordinate plane and find angles that have a sine of 1/2. Okay, so that's a major problem. So we can't really think that way. We can't answer questions that way. All of those answers are valid answers, but what we want to do is say, if I say to you, give me the angle whose sine is 1/2. If I ask this question, give me the angle whose sine is 1/2, we want to be able to give one definite answer. And the way to do that is to say, let's restrict the domain of the angles. Okay, and so to obtain a unique angle, you must restrict the domain of the sine function. Okay, you must restrict the domain of the sine function. What that means is I have to say we're only going to count angles that are between this amount of radians to that amount of radians. So I have to come up with some kind of a restriction for how we calculate the answer to this question. What is theta when sine of theta is 0.5? Okay, so a lot of background information. It says, remember that the horizontal line test is one way to determine if a function has an inverse. That is also a function. Okay, if you can draw a horizontal line on a graph of a function that crosses the function in more than one point, the inverse of the function is not a function. Okay, so this was to do with inverses and horizontal line test. And it says, using this idea and the graph of each of the trigonometric functions, you can visualize why mathematicians made certain domain restrictions to specify a domain for which the inverses of a trigonometric function are functions. Whoa, that's a lot of words. All right. So basically, if I take this thing and I say, hey, we have sine theta. What if I treat it like a function and I say y equals sine theta and I graph it? What does it look like? If you do that, you get the red graph over here. Okay, this is the graph. This red wave, we call it the sine wave. And you're going to study this more in pre-calculus, but that's the graph you get. It's a repeating graph. It keeps oscillating up and down like that forever. Okay. And so that's the function y equals sine theta right here, the red one. Now, what we want to say is, I basically want to do an inverse operation so that if I say, what's the sine inverse of theta, then I have to get back, sorry. If I say sine inverse of theta, so I can do this, let me write it like this, y equals sine theta, okay? How do I get the angle out of here? How do I solve this equation? So what you do is you say, oh, take the inverse sine of both sides, something like this, the inverse sine of the sine of theta, and then we know that what I'm going to get is whatever this answer is going to be equals to theta, because sine inverse and sine cancel each other out. So sine inverse of this number is going to be my answer for theta. Okay, so basically the answer to finding what angle am I looking for is to take the inverse of the function. But now remember, we want the inverse of y equals sine theta to also be a function. I want this also to be a function, okay? And when I take the inverse, you learned this a long time ago, the inverse is a reflection across the line y equals x. So this line right here is y equals x, okay? So the green curve here is the inverse function for y equals sine theta. But I can't, for it to be a function, remember a function has to pass the vertical line test. So for the green curve to be a function, I should not be able to draw a vertical line that crosses the green curve more than once. Okay? And so if I restrict the domain of the green curve, I can't do this. I can't say, oh, the red curve repeats, so therefore the green curve is going to do this as well. Okay? I can't do that because then what I'm coming up with is not a function. It will fail the vertical line test because it will be crossed by a vertical line in more than one place. Okay? So I can't do that. So what I have to do is say, I want to be able to use the inverse function to come up with some angles. Okay? But I need to restrict the domain of the inverse function so that it is a function. All right? So I take the inverse, and basically you see if I take this point of the function, I reflect it across the line y equals x, I get that point. If I take this point of the function, I reflect it across the line y equals x, I get that point. And basically you get the green curve. Okay? And I can't go any further because then the function ceases to be a function. Here I can't go any further because then the inverse ceases to be a function. Okay? So we say, what I have to do is say, I'm considering the function y equals sine theta only between here and here. That's when theta is between negative pi over 2 and pi over 2. Okay? So if I say y equals sine theta, I'm only going to look at that when theta is between negative pi over 2 and pi over 2. And the quadrantal angles you learned before, you know that the sine of negative pi over 2 is negative 1 and the sine of pi over 2 is 1. So that gets me here and that gets me here. Okay? If I restrict the domain of the sine function that way, then when I take the inverse of the function, I get a nice inverse that's also a function. And the inverse lives between negative 1 and 1, okay, on the x-axis, and its domain and range is switched. So this is 1 where this was 1. So this is an x1, this y was 1, and this is a x, this is a y, and this is an x, okay? So the domain and range has switched for the inverse. And so the only angles I can get back by working with the inverse function is angles that are between negative pi over 2 and pi over 2. Okay? So if I ask a question like, if I do the inverse function, if I ask a question like, which angle has a sine of 0.5, the answer is only this one. Why? Because I can only consider angles that are between negative 90 and 90. Okay? And so 5 pi over 6, as we saw earlier, 5 pi over 6 is over here in the second quadrant. And that's not between negative 90 and 90. That would break the rules of my inverse function. Okay? And so therefore, we restrict the domain of the sine function so that we can do inverse sine calculations. Okay? And so I realize that maybe for many of you, you're looking at this going, this is ridiculous. I don't understand what's going on. What I'm trying to do is satisfy some people's curiosity. Okay? There's a lot of people who go, why? And this is why. I just answered the why. Is there only one answer? How does this stuff work? Okay? So the same can be said for cosine theta, and the same can be said for tangent theta. Now, you're going to learn all about this curve right here in pre-calculus, y equals cosine theta, and you're going to learn all about this curve right here in pre-calculus, y equals tangent theta. And I encourage you, if you're curious or interested, go and see the inverse function explanation. Okay, mathematicians chose this part of the graph of cosine theta to restrict the domain to between 0 and pi, so that the inverse function is also a function, and it has a domain of between negative 1 and 1. Okay, and the only angle that comes out of there is an angle between 0 and pi. So we have to restrict our answers to the cosine of what angle, of the cosine of which angle has a specific ratio. So a question like this, the cosine of theta equals a half. What's theta? Okay, that kind of a question. We also have to do a domain restriction, and the answer can only be between 0 and pi. And then for tangent, we do the same thing. You've never seen these graphs before, but that's okay. So if I ask a question of tangent of theta equals, I don't even know if it can be a half. Let's say, what's tangent of theta? You can get something like, let's say, root 3 over 3 or something like that. Root 3 over 3, something like that. Okay. What angle makes that happen? And the answer is the angle can only be between negative pi over 2 and pi over 2. Okay, because we have to restrict the domain of the original tangent function to be between here and here, so that when I take the inverse, I get a function that doesn't repeat, that's also a function. Okay, the inverse is also a function. Okay, and so that's complicated, and I realize some of you will be unhappy with this explanation. But this is the why. This is the why, and this is the why for the following diagram that shows up in your textbook. This is what you're given in your textbook. Okay? The textbook just says, hey, memorize this, move on with your life. But that's not really a sufficient explanation. So the graphs I showed you earlier, if you read that carefully, hopefully you get that explanation. Okay? So here is the summary of all the information on the previous 2 pages. Just summarizing why it is that we do this. Okay, so here is how this works. Basically, if a is a number between negative 1 and 1, then the inverse sine of a is an angle theta, written as theta equals sine inverse of a, and the answer to the angle, what can theta be, is a number between negative pi over 2 and pi over 2. So basically what we're saying is, if you're answering a question like this, the sine of theta equals a half, and you're going to get an answer out of that, you say, oh, theta is, your answer must only be between negative pi over 2 and pi over 2. Okay? Your answer can only be one of these angles. Okay, so 90 to negative 90. If you're going to ask the question if you're going to ask the question cosine of theta is, let's say, root 3 over 2, you can only have an answer that's between 0 and 180. Okay, between 0 and 180. So you're going to say theta equals, and it's going to be something there. And then if you ask a tangent question, let's say tangent of theta equals root 3, something like that, then you're going to say, oh, theta is, and theta can only be an angle between negative pi over 2 and pi over 2. Okay, those are your only two options. All right, your answer has to be between those two numbers. Okay, so we're going to do a whole bunch of practice with this, but that's basically the gist of it. Just remember some small little difference here. For sine inverse questions, it's less than or equal to. So the inverse sine of an angle can be, the inverse sine of a ratio can be negative pi over 2 or pi over 2. But if you look at this carefully, there's no equal sign here. So you'd notice that on our previous diagram, negative 90 and 90 are asymptotes for the tangent function. So if I say which angle has this ratio, so the inverse tangent of which ratio gives me this angle, your answer cannot be negative pi over 2 or pi over 2. It can only be between those two things, but not inclusive. That's why this is shown like that. Okay? So let's go do some examples. I'm not sure if I'll do all of these with you, but let's do some examples and see what this means in practice. Okay, it's a lot of theory there. I think these pictures are good to have in your head. And I think, just memorizing these three things, probably good for you to just solve questions in practice. Okay, so cosine inverse of this ratio gives me what answer? That's the question, what angle? Okay, so what you do is you say, okay, root 3 over 2, remember that cosine is adjacent over hypotenuse, so this is adjacent and this is hypotenuse. Okay, so in which triangle or which angle do I have root 3 as adjacent and 2 as hypotenuse? Well, that seems a whole lot like this should be 30 degrees. 30 degrees has one opposite, and 60 degrees has root 3 opposite. Okay? And so what we said earlier is that the answer can either, for an inverse cosine question, the answer can either be in the first quadrant or the second quadrant. Now, think about this carefully. We did that whole all students take calculus situation. All of the trigonometric ratios are positive here, and only sine is positive here. So therefore I know that where cosine is positive is first or fourth quadrant. So the answer here cannot be in this quadrant. It can only be first or fourth quadrant. Sorry. Now I'm busy confusing myself and you. Cosine is positive in the first quadrant and in the fourth quadrant. My cosine here is positive, so I know I'm in the first quadrant. I'm not in the second quadrant. Okay, I'm not in the second quadrant because you can draw a triangle here that meets the same specifications, 30 degrees, 60 degrees, that has root 3 and 1 and 2, but this would be negative root 3. So the cosine of this angle right here would not work, okay? because that's going to give me back a negative ratio, and this is a positive ratio over here. So my answer is 30 degrees has adjacent over hypotenuse of root 3 over 2. Okay, so the answer is this. You say, since the cosine of 30 degrees is root 3 over 2, then the inverse cosine of root 3 over 2 is 30 degrees. Okay, simple as that. Or you can say, it says give the answer in both radians and degrees. 30 degrees is pi over 6. All right? So that's basically the thinking that they want you to use. Now, you can do this another way. And that is to actually just use the concept of inverses and stuff like that. Okay? So you can say, let me show you how to do this as well. You can say, I'm going to erase some of this stuff. You can say, since the cosine of 30 degrees is root 3 over 2, you can do this. If I take the inverse cosine of both sides, okay, if I take the inverse cosine of both sides, you can say that means that the inverse cosine cancels the cosine, so 30 degrees is equals to inverse cosine of root 3 over 2. Okay, but you still need to come up with this by yourself. So I'm just showing you how you can work with inverses with trigonometric functions. Okay. All right, so that's the first one. Second one, letter B, says sine inverse of 2. Sine inverse of 2. Now, what you do is you think, okay, can I come up with a ratio of 2 for sine of any angle from the triangles that I've memorized? So you know this triangle, 1, 1, root 2, and you know this triangle, which is, let's say 30, 60, which is 1, root 3, 2. Okay? Is there any way that I can do sine of any of those angles, and this is 45, 45, 90. Is there any way that I can do sine of any of these angles to come up with 2? So sine of 30 is 1 over 2. This would be root 3 over 2. This would be 1 over root 2, which is not 2. Okay? So there's no way I can go to any angle and say there's an angle that if I take its sine, it gives me 2. Now, there's something else you can consider, and that's the quadrantal angles. Okay? Now, please notice, the only quadrantal angles I need to consider is this one, and this one. Because sine inverse can only live between, the answer to this can only be between negative 90 and 90, right? Negative pi over 2 and pi over 2. So here's pi over 2, and here's negative pi over 2, and here's 0. Okay, so let's go through and see the quadrantal angles. What is this one? The sine of 0 is 0. Okay, the sine of 0 degrees is 0. Here, the sine of pi over 2, if you remember this correctly, is 1. And then the sine of negative pi over 2 is negative 1. Okay, so for me, in here, there's no angle I can come up with that gives me anything that sine is equal to a ratio of 2 or 2 over 1. So at this point you go, wait, I've exhausted all my ideas. I don't know what to do. I think this doesn't have an answer. I can't find the answer, okay? And you would be correct. So if you type this in your calculator, so let me bring up the calculator here. If you type this in your calculator, you're going to get an error, I believe, okay? And so see how long this is going to take. Okay, so if you do this, this was for my statistics class, and I'm going to just check my mode here. I'm going to put my calculator in degree mode just so we know what we're looking at when we take an inverse, okay? And you go sine inverse. Now pay close attention, you do second sine, then you get sine inverse, and sine inverse of 2, and your calculator is going to say error domain, I can't do that, okay? So what that means, again, if you go over to where we were in the beginning, we said that this value of a, okay, cannot be bigger than 1 because of our domain restriction, okay? So right off the bat, you can know that this doesn't work. So you say this is undefined, okay? There's no such an answer, all right? There's no such an answer. Okay, let's try another one. Tan inverse of negative root 3. All right, so tan inverse can only be in first or fourth quadrant, okay? And so I'm thinking first or fourth quadrant, triangle here, triangle here. Is there something I know that makes that tangent? Okay, so I want tangent is opposite over adjacent, okay? So I want root 3 over 1. Will that give me the right answer? No, that would be the tangent of opposite over adjacent here would be positive root 3 over 1. And this one would be negative root 3 over positive 1. And so you just have to ask yourself which triangle or which angle makes this happen. And you say, what has root 3 opposite? It's 60 degrees, okay? So it can either be positive 60 degrees here or negative 60 degrees. Tangent inverse is either between 0 and positive 90 or 0 and negative 90, okay? So it's not this one because this tangent would be positive. But the tangent of negative 60 would be negative root 3 over 1, okay? So you can say, since the tangent of negative 60 degrees is equals to negative root 3 over 1, we know that theta is equals to negative 60 degrees, or negative pi over 3. Okay, negative pi over 3. Okay, and then you can do the inverse thing if you want again. You can do the same thing and say, I know that tangent of negative 60 degrees is equals to negative root 3 over 1. Therefore, if I take the inverse tangent of both sides, and I do an inverse tangent here, let me move this over here, and I do inverse tangent of both sides, this cancels and I get negative 60 equals the inverse tangent of negative root 3 over 1, okay, which is the question that we were asked in the beginning, okay? And so I'm drawing pictures and stuff. You don't have to be this slow. You can be faster, you know, but I'll do maybe, let me do one more example and you can try E and F on your own and you can check the completed note sheet. Let me do, let's say letter D and then I'll stop, okay? So this is asking the sine of which angle is root 2 over 2. That's basically the question. What is theta? Okay, and so you go here and you say, I remember the answer must be between negative pi over 2 and pi over 2. So the answer can only be between pi over 2 and negative pi over 2 inclusive. It's somewhere in here. And you go, wait, root 2 over 2, opposite over adjacent. I don't have a triangle like that. Sorry, opposite over hypotenuse. There's no triangle with root 2 and 2 like that that we've memorized. The triangles we've memorized with a root 2 in it is 1, 1 root 2, and it'll be 1, negative 1, and root 2, like this. Okay, and so again, we say sine of theta is positive, and sine is only positive. All students take calculus. Sine is only positive in the first quadrant and the second quadrant. Okay, so I know that it can't be here because opposite over hypotenuse here would be negative 1 over root 2, which is negative root 2 over 2. But this one would be 1 over root 2, which is root 2 over 2. So I know that the angle I'm looking for is the angle that forms this triangle in the first quadrant, and that would be 45 degrees. Okay, so you know that you say that since the sine of 45 degrees is root 2 over 2, we know that theta must be 45 degrees, or pi over 4. Okay, pi over 4. And that's it. That's how you do all of these inverse type equations. Now, can you check yourself? The answer is yes. Your calculator knows the answer to these things. So you can check yourself. There's no reason to get this wrong. You can type inverse cosine of root 3 over 2 and you get the answer. Okay, so second cosine of root 3 over 2, and you should get the answer we had, which is 30 degrees. Okay, you can type this in, but be sure on your test you can get the answer easily, but on your test you got to show me some work. You got to show me at least a little picture or something how you got the answer. You can't just type it in your calculator. That would not be accepted. Okay, I want to know that you understand what you're doing, not just that you can find the answer quickly on a calculator. All right, so there's that. Second thing is solving trigonometric equations for a given domain. And I think we're almost out of here, guys. I think we have a few more examples left, and then we'll be out of here. I might not even do the last example. Let's see. Example 2 says, solve the trigonometric equation for the given domain. Okay, so now they're saying, give me an angle answer that is not necessarily in your restricted domain. So remember, if we say sine theta equals negative 5 over 8, the answer theta technically must be between negative pi over 2 and pi over 2. But they're saying, give me an answer that's not in that domain. So you'll see how we do this. You can still give the answer here as well. Okay, so let's do that one real quick. So what you do is this. You say, let's take their function. Sine of theta is negative 5 over 8. Now, notice, I don't know anything about a ratio of negative 5 over 8. We have no triangles or quadrantal angles that match that at all. So if you're lost at this point and you go, I don't know how to do this, then you go and reach for your calculator. Okay, so the way to do this is take the inverse of both sides. You say the inverse sine of the sine of theta must be the inverse sine of this weird ratio. Okay, and then you say sine inverse cancels sine, so theta must be sine inverse of negative 5 over 8. And what is that? I don't know. We don't memorize stuff like this. We can't memorize possibly every single weird ratio. So we go here and you do the math on your calculator. Do what is the inverse sine, okay, of negative 5 over 8. Of negative 5, oh, I typed minus. Make sure you use this key. Negative 5 over 8. All right. And what you get is negative 38.68. So let's say negative 38.7 degrees. Okay. So what I got was theta is about negative 38.7 degrees. Now notice, this is the correct answer. This is the correct answer. Sine is positive here and negative here. Can't be here, must be here. So I went down negative 38.7 degrees. That's correct. But they're asking, give me the angle theta that is between pi, this is pi, and this is 3 pi over 2, or 180 and 270. Give me an angle here. Okay, give me an angle here. Now, how do you do that? Okay, it's not that hard. All you do is you say, I have this angle, and I know that the sine of that angle gives me negative 5 over 8. So I use this angle as a reference angle. Okay, you turn this into like a theta prime. And you say, hey, let's use this as a theta prime, negative 38.7 degrees, in the quadrant that they're telling me to use it in. Okay, so I turn that into a reference angle, and I say, how about this? How about I put negative 38.7 degrees here? All right, so then what is this angle? That's the question. Okay, what is the angle? So if I use 38.7 degrees, which comes from the part they gave me, the information they gave me, this led me to my negative 38.7 degrees. If I use that as a reference angle in the quadrant they're asking me to use it in, I will get an answer. Okay, and what is the answer? The answer is 180 degrees plus I go a further 38.7 degrees. Remember, reference angles are always positive, so we don't really think about them as negative 38.7 degrees. We think about them as just a reference angle of 38.7 degrees. So the real question is, what is this angle, the blue one? Okay, so it's 180 plus I go another 38.7 degrees, and that is 218.7. Okay, 218.7 degrees. All right, so this is my answer, 218.7 degrees. So that is the angle in this quadrant that if I take its sine, I'm going to get negative 5 over 8. And you can check yourself. There's no reason to doubt yourself. Just go sine and type in the angle, 218.7, and you should get back about negative 5 over 8. So type negative 5 over 8 and see what you get. Very, very close. Okay, so that's my angle in the third quadrant that has a sine of negative 5 over 8. Right? Let's do another one. This is usually a question that students are not very happy with. So let's do another one. Okay, let's do this cosine one here. So cosine of theta is 0.4, which is 2 over 5, 4/10, something like that. We don't have, again, a triangle that precisely gives us this angle. So what you do is you say, okay, I don't know exactly how to come up with this theta. So what I'm going to do is do an inverse cosine operation. Okay. And I'm going to say theta is inverse cosine of 0.4. Please, you don't have to do this first step all the time. I'm just showing you exactly what it is you're actually doing when you say theta is cosine inverse of 0.4. Okay? And so what we're going to do is get an answer. Again, I can't do that. I have to go to my calculator and go second cosine inverse of 0.4. Give me an answer. And it says 66.42 degrees. Okay. This says theta is approximately 66.4. Let's just leave it at 66.4 degrees. How about that? Am I right? Is it 4? 66.4 degrees. Okay. And so I get this. And good. What do I do with that? Okay. Well, they're saying this is nice, but we want the angle in the fourth quadrant over here somewhere. okay, that has a cosine of that angle that's equals to 0.4. Okay, so I'm shopping for an angle theta that if I take its cosine gives me 0.4, but that angle must live in the fourth quadrant. Again, what do? Just use this 66.4 and consider that your reference angle, and go here and say I want to use this as a reference angle, 66.4 degrees. Okay, and so what angle is that? Well, if I use this as a reference angle, I go all the way here and I say, what angle is that? Okay, what is the angle that has 66.4 degrees as a reference angle? Must be a positive angle, must be in the fourth quadrant. So you go, okay, I'm almost at 360. I'm not quite there. If I subtract 66.4 from that, I will get the angle I'm looking for. Okay, so if I do 360 minus 66.4 degrees, I will get my 293.6 degrees. I think that's correct. Let me just double check myself. Yeah, 293.6 degrees. Okay, so this angle out here is 293.6 degrees. Now you'll notice in the first one, we actually added because I went past 180 to my reference angle. In this one, we're actually subtracting because I'm not quite at 360, okay? So I'm saying it's 66.4 degrees less than 360, all right? And remember, we're always working from the x-axis with reference angles. So if I go past, I add. If I'm not quite there yet, I subtract, okay? Let's do one more and then I'll stop. I think usually this is not students' favorite math right here, okay? Let's do one more of these and then I'll go to the next type. These are all kind of the same. Let's do tangent, okay? So tangent of theta equals 2.1. I don't have a triangle for this. I don't know a quadrantal angle for that. So I'm just going to go to my calculator and say, oh, sorry, I didn't. You can just directly do this. Theta equals inverse tangent of 2.1, using the same logic I showed you before. And so you can just go, what is inverse tangent of 2.1? And if you do that, you get about 64.5 degrees. So you say theta is about 64.5 degrees. And now again, they're asking for us to find the angle in the third quadrant that meets those criteria. Here's 180, here's 270, okay? So if I use this as my theta prime now, reference angle, I just go here and I say this is 64.5 degrees. And you can see, since I went past 180, I need to add to 180. So the theta I'm looking for is actually 180 plus 64.5 degrees, which is 244.5. Okay. And what I did in my notes, I wrote, because this is very confusing. You're writing theta equals 66.4, and then you write theta equals 360 minus that, which is 293.6. But what I did in my note sheet is I just wrote here in quadrant 4, and this one is in quadrant 3. Okay, just so it's clear which theta is which theta, so you don't get confused with why is there two different thetas. All right, something like that. Just a quick little, you know what you're doing, you know how to find angles in space and find their inverses. Okay. All right, example 3 talks about finding measure of angle theta in the given triangle. All right, so again, look at these triangles. None of these sides are things we've memorized, so you can't come up with 45 degrees or 30 degrees or 60 degrees or 90, 180, 270, any of that stuff. These are not ratios that I'm aware of, okay? And they're all of these theta angles obviously must be acute, okay? So I have no other way of doing this except doing it on a calculator, All right. So all you have to do is say, if I'm approaching the triangle from this angle, how can I find what that angle is? So I use the two pieces of information I was given. Here's an adjacent side, and there's the hypotenuse. So adjacent and hypotenuse is cosine. So you just do cosine of that angle, theta, is the adjacent side over the hypotenuse. Okay? But that's pretty much what we had here. Now, how do I find an angle out of there? Well, all you do is just do the inverse. Okay? So you just say cosine inverse of cosine theta is cosine inverse of 4 over 9. You don't really have to write this step. You can skip straight to this. Okay? And then just give me an approximate answer. And again, for this kind of stuff, 4 over 9 is not something we know. You just go straight to your calculator and do cosine inverse of 4 over 9. And you get 63.6. And I'm in degree mode. Okay, 63.6 degree mode. All right? And since they didn't say how to find the angle, you can just leave it in degrees. In the previous example, they said... actually, in the previous example, they didn't tell you either. They said give it in degrees. I guess they did. And then in the previous example, they said both radians and degrees. Okay? So pay attention, close attention to how they're asking the question. All right. And then that's that. Let's do one more. Maybe... yeah, let's do one more. If I'm coming from here, let's do C. And I'm going to do, all right, I have from the perspective of the angle, I have an opposite and I have a hypotenuse. Okay? So opposite and hypotenuse, that would be sine. Sine of this angle is the opposite, which is 5 over 12. And I go, that means that inverse, theta is the inverse sine of 5 over 12. Okay? And if you do that calculation on your calculator, I'm not going to go do that again. You can do that yourself. You get 24.6 degrees. There is one thing I forgot to mention right at the beginning here that I just want to go back to. Okay? There is one thing I want to mention right off the top. And that is, let me go back here and erase some of this scratch on here, and then we can talk about this. When we say these things, sine inverse, cosine inverse, and tangent inverse, please, we are not saying this. This does not mean 1 over tangent. Okay? That is not what we're doing here. That's not what we're doing here. If I wanted to say 1 over tangent, I would say cotangent. Okay? That's what I would say. All right? That's not what we're doing here. What we're doing here is the operation that is the inverse operation of taking a tangent of an angle. So taking a tangent of an angle gives me a ratio. Taking an inverse tangent of a ratio gives me an angle. So there are inverse operations. This and this are inverse operations. Okay? So they give back inverse information. All right? Please don't think of it as a 1 over situation. That's not what we're doing. All right, let me do example 4 with you, and then I'll stop. I'm not going to do example 5 with you. Example 5 is actually quite tricky. You can go try that sucker and then look at the completed note sheet. I'm not even sure if this is on the completed note sheet. This is quite tricky, okay? But I'm not going to do that one. I don't want to make this video any longer than it has to be. So let's do example 4 and we'll stop. Let's do at least one problem here, okay? So it says different types of granular substances naturally settle at different angles when stored in cone-shaped piles. The angle theta is called the angle of repose. Okay. So think about this granular substance, let's say sugar or something. They're talking about salt, okay? So let's say salt. I take salt, and when I store it in a cone-shaped pile, so think about a truck with like a big pipe, and the truck has a big pipe here, and it's pouring out salt, okay? And the salt settles in a cone-shaped pile, which this is actually real. That's exactly what would happen if I pour salt into a position. Okay, it says the angle theta is called the angle of repose. Okay, so settling at different angles when stored in conchite piles, the angle theta is called the angle of repose. If I were to draw this, and then I draw, let's say, a horizontal line here, okay, this is the angle of repose, the angle that the side of the pile makes with the horizontal. Okay, that's the angle of repose. All right, and so this is what we would call theta right there. Okay, so when rock salt is stored in a cone-shaped pile that is 11 feet high, the diameter of the pile's base is 34 feet. Okay, so when the height from the top perpendicular to this, to the surface, the ground, okay, when that is 11 feet, the diameter, in other words, this blue distance here at the bottom, the diameter is 34 feet. Okay? Okay? And then it says, if another pile of rock salt needs to be made, there's only enough room for a pile with a diameter of 46.4 feet. How high should the pile be? Okay? So, if I want to make another... Oh, not a line. Don't give me a line. If I want to make another pile of rock salt, rock salt, okay, and there's only enough room for a diameter of 46.4 feet, okay, how high should this be? How high should this be? Okay. That's the question. What's the height there? Now, let's see. Different types of granular substances naturally settle at different angles when shaped in piles. This angle is called the angle of repose. Okay? So, what we're saying is this angle of repose here must be the same for this pile and this pile, because they're both rock salt. Okay? They're both rock salt. So the first sentence said, if I'm rock salt, then I settle at an angle of repose. Okay? And so both of these piles are rock salt. So what I can do is find this angle theta, okay, using the information in the first rock salt pile. And then if I can use that angle theta here for the second one, then I can find out my height. Okay, so let's do that. Now, you have to make a few little assumptions. There's an assumption here that this is the perpendicular bisector of the diameter. Okay, that it's perfectly, the tip of the cone is perfectly centered in the middle, so that the height is a perpendicular bisector for the base. Okay, so yes, let's hope that's happening. And then we'd have to say that we know that this distance is 17 feet. Okay, and so now I can do a calculation. I can say, if I'm looking from the perspective of angle theta, I have an opposite over adjacent situation. I know the opposite side and I know the adjacent side. So I can say the tangent of theta is 11 over 17. And then you can say, take the inverse of both sides, which means tan inverse of tan theta. And again, you don't have to write this. I'm just doing it to be explicit. These cancel each other out because it's inverse operations we're talking about. And then you get theta is about, and if you do that on your calculator, I've done it already, you get 32.9 degrees. So now I know immediately that this angle of repose is 32.9 degrees, and this one is also 32.9 degrees, because both piles are rock salt. Okay, so the angle of repose is the same. All right, so now all I have to do is find h. Well, let's make that same assumption. I really can't do it any other way. That this perpendicular bisector chops the 46.4 feet in half, and that would mean that this little distance here would be 23.2 feet. Okay, now I can find the height, the maximum height that I have to be able to pour my rock salt. Okay, so I go, all right, again, I have from the perspective of this angle theta, I have an opposite over adjacent situation. So I'm still doing a tangent, but this time I'm doing this slightly differently. I know the angle of repose. The tangent of 32.9 degrees is some unknown h over 23.2 feet. Okay, and notice I didn't write feet here because the feet cancel each other out, but the feet is actually important. So if I solve this for h, you get h is multiply the 23.2 feet to both sides times tangent of 32.9 degrees. So what is the height? It's about 23.2 feet times tangent to 32.9. It's about 15 feet. Okay, it's about 15 feet. All right. That's a nice little easy doable problem. Not too bad. Okay, this is a reasonable thing to expect on an assessment. All right, and then like I said, example 5, you can go crank through that. That's pretty tricky. If you have a question about that, you can join me in a conference. We can talk about that. If you just want to skip it, knock yourself out. Okay guys, thank you.